Hello everyone, I welcome you all for a lecture on restricted assignment problem. This is one of the lectures in the series of lectures on the operations research. We are discussing here assignment problem. As this is a special case of assignment model, we have to obtain the solution. Now what is meant by restricted assignment? Restricted assignment is nothing but where certain resources are not allocated due to a certain difficulty or there is a limitation or prohibition of allocation. Now let us discuss first what is the concept of restricted assignment problem. Now assignment with restrictions. So it is sometimes possible that a particular person is incapable of doing a certain work or a specific job cannot be performed on a particular machine. So this can happen depending upon the skills or availability of machine's characteristics for doing jobs. Therefore, at that places, the certain resources cannot be assigned or allocated. Now, while obtaining the solution for such problems, we should take into account these restrictions so that at these restrictions, in the final solution, assignment is not made. Now our intention or objective is same here, to minimize the cost, distance or time. Now this can be achieved by assigning a very high cost, infinity or big M or capital M to the cells. If we assign very high cost at the place of restriction, at that place in the solution we never get a zero value after mathematical operations. So therefore the assignment is not possible at these places. Therefore assignments are restricted, prohibited, and hence in the final solution we don't get there any assignment. So this is concept of assignment with restrictions. Now let us discuss one problem here. Now the problem is a job shop needs to assign 4 jobs to 4 workers. The cost of performing a job is a function of the skills of the workers. The table summarizes the cost of the assignments. Worker 1 cannot do job 3, worker 4 cannot do job 4. Now these restrictions are given. Worker 1 cannot do job 3 while worker 3 cannot do a job 4. And we have to obtain or determine the optimal assignment by using Hungarian assignment method. In the solution we will have to introduce here either capital M, big M value or infinity. Usually I use here infinity symbol at the places of restriction. So I have solved this problem on a plain paper and I will explain its steps in the next slide. In this step I have introduced a value infinity at the places of restrictions. So when we are going to solve this problem, let us solve this problem having the values infinities in the given table. All the values I have taken as it is from the problem table here. Now once we introduce the infinity value here, then let us perform a row operation. If you consider here a row operation, consider a smallest value in each of the rows and subtract it. For first row, smallest value is 20, subtract that value, we get these values in the new table. Similarly, in the second row, smallest value is 20, subtract 20 from all the second row elements, we get these values. Similarly for third row and fourth row. So we get this row operation table, or sometimes it is called as row minimization or row subtraction. Then once row operation is completed, next step as per Hungarian assignment method is to perform column operation. So column operation we can perform column wise. Here we have to find out in the row operation table which is the smallest value in each of the columns and subtract that value from each of the column elements. In the first column, smallest value is 30. So 30 subtracted from all the first column elements, we get here this new table with first column where each of the value from each of the value 20 is subtracted. 30 is subtracted. In the second and third, fourth columns there is already 0 present, so there is no subtraction possible, hence these columns get repeated. Now once we perform row operation and column operation, we have to check for optimality on the basis of assignments. Then make assignments. While making assignments, our first step is to locate a row which has exact 1 0 element and go successively. Here in the second row there is exact 1 0, therefore assign this 0 first. Now check whether in that column any extra 0 is available. There is no availability of 0, so we cannot cross any of the zeros. Then observe in which of the row there is exact 1 0. So in the third row there is exact 1 0, therefore assign this 0, and if any extra 0 is available, cross it. Again observe whether there is availability of any 0 in a row which is having exact 1 0. So there is no such possibility. Now go column wise. If we observe column wise, we get here exact 1 0 in first column. So assign that 0, and in respective row cross that 0. So there is no further possibility of assignments. Now check here how many assignments are there. Assignments are nothing but the squares which we have drawn around the zeros. So here number of assignments is equal to 3, number of rows or columns equal to 5. Therefore solution is non-optimal. If the solution is non-optimal, we have to improve it by drawing certain set of lines. But while drawing the lines, we have to mark first the rows and columns so that we can improve the solution in unique way. First, identify a row which has unassigned 0. So here row number 4 is unassigned. So mark that one first. Then select a column which contains this unassigned 0. Mark this column. Now in the marked column, select a assigned 0 and mark the respective row. Now whether there is any possibility of having a unassigned row, there is no possibility. So therefore let us draw the lines now. Let us draw the lines for unmarked rows and marked column. It covers all the 0 elements in the matrix. Now select a row, select a smallest uncovered element. There are uncovered elements 20, 30, 20, infinity, 50, 40. Smallest is 20. So subtract this uncovered element from smallest uncovered element from all the uncovered elements and add this value at the points of intersection. Therefore we get a new matrix as this one. Now 20 value is added at the intersections, while from uncovered elements 20 is subtracted. The points or values which are just covered but there is no intersection, they remain as it is. We never change their values. Now this is the modified table now, and again we have to check for optimality by making assignments. So here in the new table, first assignment will be in a row which has exact 1 0. So if we observe first row there are multiple zeros, then we will skip it. In the next zero, let us observe where is the exact 1 0 element. Then let us make assignment, then cross it, extra zeros in the respective columns. Similarly, go on making assignments and let us check for optimum assignment. Now if you observe here, we got here 4 number of assignments and 4 number of rows or columns. Therefore solution is optimal. We get here optimal solution because the number of assignments are equal to number of rows or columns. The number of assignments are 4, number of rows or columns are 4. Hence the solution is optimal. Now we have to give the final answer. Our final answer will be, we have to write down the assignments, and with reference to the original cost matrix, we have to put the values located at these cells. So hence write the assignment and write also the values located at these cells. Then let us find out the total cost, which is minimum, by simply addition of this cost element. So this is our final answer. So this is the total cost, rupees 140. I hope you have understood this problem. Thank you.